The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. Hopefully you can hear me okay. We're going to start today's webcast by looking at sustainability, and then we're going to take a look at a tool called SolidWorks Plastics as well. It's following on from the product design theme that we've been working with over the last few weeks. So firstly, I just want to introduce SolidWorks Sustainability. It's actually a full life cycle assessment tool for your product. So it does take into account the raw material extraction, depending on the material you're using, the transportation from there to the material processing itself, then the transportation from there to part manufacture, through to assembly, product use, and then end of life as well. So it is a complete sort of cradle to grave system. SolidWorks have partnered with somebody called PE Americas, which are quite a large outfit looking at life cycle assessment on certain materials. If we go through into SolidWorks, we'll take a look at how sustainability works within the system. So we've got two variants of sustainability. There's Sustainability Express, which is in every version of SolidWorks, and then we also have the full version of sustainability as a separate product that you can purchase. The differences are Sustainability Express is used for single parts, whereas the full version of sustainability has a lot more configurable features, plus it has the ability to work at assembly level as well. So as you know, within SolidWorks we can create our assemblies, we can assign materials to those assemblies to give us weight, density and things like that, but the assigning of those materials can then be looked at with sustainability as well. So if we go ahead and start sustainability, it will open up on the right hand side for us. It does take a little while to first start out because it's going to calculate a fair amount of information. Okay, so if we take a look at it as it starts up, it's actually looking at the assembly process at this stage. So it's looking at where the assembly is put together, how many years is it built to last, is there any energy required for the assembly process, which we can specify. So within here we could specify gas or electricity if it was required. We can then also specify a use region and any energy used over the product's lifespan. Now, in order to get from the assembled region to the manufactured region, is going to have to be transported, and here we can configure certain elements. So basically, being manufactured in Asia and used in North America, it's going to have to go on a boat, and we can specify a distance. This distance here is a default value and is typically the coast-to-coast distance, but it may be that it's used in a certain area of North America, so it may need to go via a truck from the coast to that particular region, so you can build that into your calculations as well. Or we could send it via a plane if we wanted to. So there's some nice configurable options there. We can also specify the amount of recycled content at end of life, incineration and then landfill as well towards the bottom. So that's for the assembly process, actually putting the product together. We're going to take a look at an individual element of the design. So if I select one of the items, you'll see here the system reverts to that particular component within the assembly, and it will show us what the material we specified in SolidWorks is. So you can see here that we're using a plastic, an ABS plastic here. We can change that to any one of a variety of different plastics within the system, but the really nice feature within sustainability is something called this Find Similar button here. So what we can do if we launch this tool is it will allow us to search the database for a similar material dependent on properties that we specify. So for example here, if we're looking at that main body, you may remember a couple of weeks ago we did a pressure test on the inside of that component just to understand whether or not it was strong enough, and it was deemed to be strong enough. So the material we'd chosen for this particular product was fine from a strength perspective. So if we were looking for another material, we know we're going to make it out of a plastic, so we can specify for the system to only look for similar materials within the plastic section. And we may want to keep the tensile strength the same, so we don't want anything weaker, but we're happy with anything stronger, so we can specify that option here. We've also got a new button in the last few releases which allows us to specify the financial impact of the product as well. So we can say here that we don't want, or we want something that is less costly as a material. So we can use any number of these properties here. So these are the mechanical properties for the material. So if we click Find Similar here, it will give us a filtered list of products that satisfy that criteria. Now that in itself is quite nice, so we can look through here and see those materials. But the great thing about sustainability is towards the bottom here it's actually showing us the carbon usage, energy usage, air pollution and water pollution for the ABS plastic that we've chosen. So what we can now do is go through the list and specify another material and understand if that is better or worse for the environment than our current selection. So we can see here that the acrylic that I've picked on first is actually much better across the board on all the factors that sustainability is measuring. And also the financial impact of the material is 16% less as well. So that may be a good choice for us to make, but it's not typically a material that we would use in this type of product. So we can go through here and take a look at some of the other ones. You'll see red is bad, green is good. So it calculates on demand as well for you. So, you know, it's quite a nice dashboard arrangement for you to get a good understanding of whether or not the environmental impact of the material choices you make is better or worse. We're going to stick with our ABS purely because it actually wasn't that bad in the first instance, and there isn't another plastic that suits the bill within here. So we're just going to cancel out of this screen. So if we select back on that component, so once we've chosen our material at the top here, if we scroll down we can take a look at some of the other options within sustainability that we have as well. So very much like the assembly process, we can specify a manufacturing region. So in this case it's manufactured in Asia. Maybe we can specify that it's built to last for 3 years. The process is injection molded. You'll see we've got extrusion or injection molded for the plastic components there. We can also specify the amount of energy used in the process. So here we've got electricity, and we've also got a scrap rate as well added on here. We're using default values that the system actually puts in for us, but if you know those values you can override the defaults and make changes to those if you want to. So again, very much like the assembly section, we've got a use, so we can specify a region for the use of the product. Again, we can drop down any of the major geographies there. And again, we can configure in terms of the transportation, individual elements of that transportation chain. So as I mentioned earlier, maybe if it's manufactured in Asia it may go on the train to the boat, so we can specify that distance, and then once it gets to America from the boat it may go on a train and then a truck, for example, but we'll leave that as the default values there. And again, towards the bottom we can specify the end of life percentages for recycled content, incineration and landfill. Okay, so if we go back to our main dashboard here, you can see that we've got these values towards the bottom here which show us the percentages that we were referring to earlier. So the amount of carbon used, energy used, air pollution. So that tells us there, if we just take a look at that one specifically, it tells us a little bit more about what that's doing. So it's saying sulfur dioxide, nitrous oxides and other acidic emissions to air cause an increase in the acidity of rainwater, which in turn acidifies lakes and soils. So it's just taking into account that, and that's actually measured in sulfur dioxide there. the water eutrophication. So again, that's like wastewater coming out of the plant going into the surrounding areas. We can measure that. And these are all values that come from the sustainability materials database, which is actually very comprehensive. So a lot of other systems have similar products, but one thing that sort of sets SolidWorks sustainability apart from the others is the partnering with PE International, this large American firm. They've got over 20 years in the industry of looking at material life cycle assessment, so the data is actually very accurate. Some of you who may know a little bit about sustainability products, there's a system out there called Gabi, which is a very expensive system, but effectively we're a slimmed down version of that software. Okay, so let's say, for example, we want to take a look at how a couple of different aspects in terms of how we where we assemble the components. So what we can first do is specify this as our baseline value, and then maybe make some changes at the top here. So let's say we assemble in Europe. We can cut out a degree of the transportation costs involved there in getting our product to the use region. And you can see here that we've made some changes to our little graphics down the bottom here. We've reduced the carbon by 1%, energy by 1%. The air pollution has actually gone up by 1%. But we can compare any changes we make against the baseline values that we specify. Okay, so if we just go back and take a look at our assembly, there's something else I want to show you as well, which can be quite helpful to sort of measure the environmental impact of your products. And that's something called assembly visualization. So if we start assembly visualization here, what we can do is add in a column here. So maybe we want to look at the energy usage involved in actually producing some of the components in our design. So we can specify that as a property. We can add that into our assembly visualization, and for those of you who've seen assembly visualization before, it allows us to organize our components based on their weighting. So here we can see that the main body component is actually using the most energy in its production, in its manufacturing process. And we can choose any number of factors from the sustainability calculations to measure those here. So maybe I'm somebody reviewing the design. This is a really nice way for us to look and see which one carries the most financial or sustainable impact. And we could take a look at that product and maybe choose a different material using the Find Similar button. So quite a nice tool for that kind of thing. Okay, so moving on from there, maybe what you want to do is sort of highlight to your customers that you're using sustainable design. Maybe you want to advertise it on your website, that kind of thing. What we can actually do from SolidWorks Sustainability is create a report. So we can generate a report from here like so. So we can say we want to generate a sustainability report in a Word document format. We can do it in a CSV format as well if you want to. Or alternatively, if you do have a system or access to the Gabi software, we can actually output a file that Gabi can then read in and do a more in-depth understanding of the sustainability of the material choices we've made. So if we save that document, we'll save it to the desktop. Okay, we can just say OK. Then that's going to publish the information that we've gathered doing our life cycle assessment and produce a report for us. So we'll just let that work its magic. And if we take a look at this item, you'll see, let's just zoom in a little bit so we can see here. So you can configure this with company name and logo. We can view some details about the model, the manufacturing and the use region. We can take a look in a little bit more detail as to the duration of use, the energy used, that kind of thing. And then if we scroll down here, We'll just zoom out a little bit more so we can see that. You can see the values that are calculated for the carbon footprint, energy consumed, air acidification and water eutrophication values there. And we can see how much the material costs. We can then take a look at the top 10 components contributing most in those 4 areas. So again, a nice sort of way for you to see which ones are impacting more on the environment. You can also take a look at the baseline that we'd specified. You can do this for the assembly and also individual components as well. So it depends on what you want to look at. So quite a nice document that's produced automatically, and it does show people that you are thinking about the sustainability of the products that you're producing. Okay, so that gives us a brief overview to sustainability. We can see that in a little bit more detail in some of the previous webcasts that we've done on this subject. The next thing that we're going to look at is a product called SolidWorks Plastics. So this will allow us to understand whether or not our product will actually have the ability to be manufactured. So will it fill with plastic? Are there any problems? We're going to be taking a look at some of the features within Plastics Professional first. So the first one there is, will the product fill? Secondly, we can look at, are there any weld lines in the design that may impact the cosmetic appearance of faces? Do we need to use multiple gates, for example, to fill the product a little bit more efficiently? If you're looking at thin-walled components, if that's what you design, you can also look at whether or not you will get short shots. So, you know, that's where the plastic doesn't completely fill the mold. And we can also look at air traps in the design as well. So ideally we want to have those on mold split lines or vent them out to the atmosphere, that kind of thing. In the premium package we can also look at some other more complicated things. So we can look at multiple cavity molds. So if you are doing family moldings of 2 sides to a component within one mold, we can take a look at that. We can also do quite a complicated design of runner balancing. So this is where if you've got 2 different sides to a casing, as an example, that are different volumes, you may want, or you do ideally want those to fill at the same rate, just to ensure that they cool then at the same time, and you're getting a sort of continuity of quality in those 2 items. So we can actually perform a runner balancing analysis within the system that will alter the dimensions of the injection points that you're using to give us a better fill time that's matched across both components. We can also do overmolding, sink mark analysis. We can look at the cooling times. And if you are using fibres within your plastics as well, so maybe there's a glass fibre in there, we can take a look at that and see in which direction the fibres are laying once the product has been injected with plastic. Okay, so if we switch back over to SolidWorks, we'll just close sustainability down. We don't need to save that. And we will just open up one of the components here and take a look at SolidWorks Plastics in a little bit more detail. So we'll just remove this appearance so we can see what's going on. So we can see in a little bit more detail. So we're going to take a look at this as a whole portion. We're not going to split this into 2 sections. We're going to try and use plastics to actually analyse that as one item. So the first thing we need to do is take a look at the plastics manager here on the left hand side. For those of you who don't have plastics, it is driven as an add-in in SolidWorks. It is an additional product that you need to purchase. If you do want some more information about that, then please feel free to give us a call. So if you are going to use it, it is an add-in. We need to turn that on. So you'll see that it's on in my system. It has its own toolbar and it's fully integrated into the SolidWorks system, so we don't need to change any windows or open a different product, which is a real time saver. So if we go into the plastics manager here, we'll take a look at the tree, and typically with any simulation product we tend to work from the top down in terms of how we actually set this up. So the first thing we need is a mesh, and we can do either a solid or a shell mesh. So Just to give you an idea, a solid mesh will completely mesh the internal regions of the component. A shell mesh is slightly different to the shell mesh you may be familiar with in SolidWorks simulation. The shell mesh in plastics will actually mesh all the external faces and leave the cavity empty. So it's a slightly different system, but still very, very effective. So we can do this either automatically or manually. So if we use the automatic settings, the system will go away and create the mesh for us on that file. If we use the manual settings, we can configure the triangle element size if we want to, that type of thing. The next stage maybe is to design some runners to actually fill this, but we're gonna position a gate directly onto the component just to save us a little bit of time. And then after that we move on to the input section. So the first configurable option we have within input is the material that we're using. So if you remember back, we're actually using an ABS material, but if we take a look here, we'll just open the database. For those of you who do specify materials, within ABS there's actually a huge number of suppliers of ABS and particular grades of ABS that we can specify. So you'll see here, I'll just scroll through the list a little way. You can see there's actually quite a large amount of different types of ABS from different suppliers. Each of those ABS plastics will have its own material graph, as seen on the right hand side here, with different properties for viscosity, specific heat, thermal conductivity, that type of thing, which all go to impact how that plastic can actually be injected into the mould. So if you don't know what particular grade of ABS you're using, you can actually specify a generic material like we have at the top here. There's some nice sort facilities within here and a search box so we can search for particular grades of material. So if we say OK to that, our material is defined. The next thing we can do is specify the machine that's being used for injecting this. Again, you may not know the particular machine that's being used, but if you do, you can actually specify it. And again, there's quite a large range of different machines from different manufacturers. You'll see here we've got Arbergs, Cincinnati's, some other ones here. There's a fair amount. What you can also do is specify a default machine. So again, if you don't know the type of machine you're using, you can actually just use the default values. And each of these machines has its own specification for the injection unit, the maximum injection pressure, the injection rate, screw speed, those kind of things, along with clamping unit details, hydraulic unit, and some general options as well. Okay, so once we've selected a machine, we can just say OK. There is another section here on the process. These settings will fill automatically. So we don't need to worry too much about those unless we actually know the values. The final thing we really need to do is specify the gate position. So that's where the plastic is going to be injected into the mould that we're working with. So if we open the settings for this, we get the chance to choose a particular element within the mesh for us to inject the plastic into. So ideally these want to be away from cosmetic surfaces, but I'm just going to pick this section here in the middle of the mould like so. And we can specify a diameter for the gate, so we can choose whatever diameter that happens to be. And we can also specify multiple gates as well. Once we've chosen a location, we can just click add, and that will add that gate onto it for us. And we can just click the green tick. So that's really all we need to do in terms of setup. We can adjust those and go back to them at a later date, but really all we need to do now is actually run that simulation. So we just we'll just not replace the results, and well, actually we better have. It shouldn't take too long to run, hopefully. Keep your fingers crossed. But what that's going to do is it's actually going to fill the mould, and you'll see as that's working along we can start to see the plastic moving through the component in the way that it would in real life. So even now we can start to understand how the plastic is moving through our cavity. You can also see we actually get some readouts in terms of the injection pressure that's required at the current moment in time. So you can see that's building up from 4.75 megapascals to nearly 6 megapascals there. And what we'll get at the end is a summary of the injection pressure that's required to fill that cavity. Okay, so that shouldn't be too much longer. You'll see just before it's finished as well, we get access to some of the graphs over on the left-hand side that we can review some of the results or partial results if we want to as well. But we'll let this finish. It's nearly there now. So this product has seen some improvements as well over, we've sort of brought in towards the start of last year. We have seen some improvements in it this year as well. So we'll take a look at some of those improvements. I'll certainly point those out to you as we just review some of the results we've got. The first thing is the results advisor on the right hand side here. This has been completely overhauled just to give us a much better understanding of what's actually happening. So a nice box for new users is this top section here. So this just reviews the data that it's got, and it tells us that the required pressure to inject here is 23.7 megapascals and the clamp force for the mold needs to be 10.48 tons. So it says the injection pressure is less than 66% of the max pressure limit. That's for the machine that we're using. And it does also tell us that the part thickness could be reduced by 25% and still be able to fill. So we may need to look at that alongside some simulation results to understand whether we can alter the wall thickness of the design. So that's our fill time plot, and if we look over on the left hand side we can click the play button and start to understand how the cavity is actually filling with plastic. So it just gives us a nice graphic there. I'll just highlight one area in particular. You can see the plastic moving around this cylindrical section and then rejoining at the top. That's typically where we would see some weld lines in the design, where the plastic splits, goes round an obstacle and then rejoins. And those weld lines do sort of cause cosmetic defects, or can cause cosmetic defects. And we can actually look at those by turning on an option within the system, and you'll see here that those weld lines sort of show up where those flow fronts rejoin along the top here, giving us a good indication of that. Anything on the inside of the cavity may not be too much of a problem, but that gives us a nice understanding, and we can see that predominantly on the main body there isn't any weld lines that we need to worry about. A lot of them tend to be confined to what in reality would be the split line of the mould anyway, where we should get some flash lines. Another option that we can look at is the air traps. So here we can take a look at where the air is being forced out of the cavity and where that sort of ends up. So you can see that a lot of those are at geometry limits, if you like. There's not a huge amount of those in the middle of the part, so chances are they should be easy enough to vent from there, which won't be too bad. And they're not on the major portions of the design where we wouldn't want to see any cosmetic degradation. So within the system we can also take a look at the ease of fill. So it will give us a good grading here of 0, 1 and 2, and you can see that everywhere on our cavity is easy to fill. We can take a look as well at sink marks. So where there's any changes in thickness of the wall thickness, we may get some sink marks. And we can see here running along this main cavity, what we've actually got is an internal feature that sort of doubles the thickness at that area, and that sort of highlights a possible sink mark location there. So we may need to take a look at that if we were refining the design, or it may not be too much of a problem. It gives a predicted size as well for that sink mark, so you can see in reality it's around 0.01 of a millimetre, so not a huge amount, but it may still be noticeable. Other details you can get for here as well are things like the shear stress at the end of fill. So One of the things that's important in moulded products is what we would refer to as the moulded in stress. So when the plastic actually cools, it starts to cause the component to warp, and we can actually output this shear stress at the end of fill into simulation so that we can start to understand what the warpage of the design may be. That's a recent addition to the plastic suite of products that we had brought in 2014, so quite a new piece of functionality, that one. We can also take a look at the cooling time as well to understand how long it takes to cool, which areas take the longest to cool, that kind of thing. So there's some really useful results within here as well. And you get a good description of what the cooling time is based on over on the right hand side as well. Okay, so that sort of summarises plastics quite nicely. If we take a look back at our slide here, just for your information, there have been some previous webcasts on plastic as a complete product, so if you are interested in that, it may be worth finding those on our website, or alternatively just give us a call and we can discuss that with you. Okay, so thank you very much for watching. We're going to continue our product design series webcast next week with the mould creation for the main body component we were looking at in plastics. And then we have a break on the 31st of October for our customer day, and then we'll return the following week to have a look at how we can create instruction manuals with SolidWorks Composer. And then the week after that, just to finish us off, we're going to take a look at how we can create rendered images and use display states to change colours within SolidWorks as well. Once again, thank you very much for watching, and do get in touch if you want any information on what you've seen today. We'll probably got a little bit of time left to take some questions if anybody has any. I'll just have a look here. Let's have a look. So Tom asks, what's the incremental cost on top of the basic SolidWorks seats for plastics? Good question, Tom. Off the top of my head, I believe SolidWorks Professional is around the 4K mark, and SolidWorks Plastics Premium is around the 9K mark. It may be worth me just jotting down that question, Tom, and I'll drop you an email with the details of those prices exactly for you. So Andrew asks, what is the customer day? So good question, Andrew. I know you're a relatively new customer to us, so you're probably not 100% sure of what that is. So every year we do we invite all our customers along to have a look at the new version of SolidWorks, and this year that's on the 31st of October at Duxford. So you should have received an invite. If you haven't, I'll drop you an email with one of those on there. It's on our signatures at the bottom of the emails that we send out, and you can register on there and come along and have a look at 2014. We'll be doing some other breakout sessions on certain things as well, tips and tricks, that kind of thing. But I'll get an email sent out to you, Andrew. Okay, any other questions? Okay, well, thanks very much for watching. You know, as per normal, this webcast has been recorded, so we'll put that up onto our website so that you can watch it again if you need to. And as I said, any questions, if you want to know anything at all, just give us a ring or drop us an email. Thanks very much.